So hello students, welcome to third session of groups. So in last session I discussed a theorem. So that is order of an element does not exceeds the order of the group. So if you consider any element of the group, its order is always less than or is equal to the order of the group. So group na order ಏನಿರುತ್ತೆ ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ element na order ಇರೋದಿಲ್ಲ. Okay. If it is an infinite group, the elements may have an order of an infinity. Okay. So now in today's session, I would like to discuss some more important theorems in groups. So that is the order of an element of a group is same as that of its inverse. If you consider any group or in any group, every element has its inverse. Every element has its inverse. So if you consider the order of an element and its order of its inverse, okay, so they are same. So that is in a group G, order of A, so suppose A is any element of group G, so then order of A is equal to order of A inverse for every A belongs to G. So we need to prove this theorem. So it is a property. Yes, to prove this property, here we have two cases. Two cases. One is so that group may be of infinite order or it is a finite order. So first to consider that, so order of an element A is infinity. So in that time we have to show that its inverse also of the order infinity. Yes, to prove this, we take the case 1. So in case 1, first case, you take that let the order of A be infinite. Let order of A be infinite. So in second case, we have to take order of A is finite. Okay. In first case, you take that order of A is infinite. So now we shall show that order of A inverse is also infinite. So now we shall show that order of A inverse is also infinity or infinite. Okay. To prove this order of A is infinite, you just assume that order of A is finite. Then what happens? So ಈಗ order of A inverse infinity ಅಂತ ಪ್ರೂವ್ ಮಾಡಬೇಕು. ಬಟ್ ಅದಕ್ಕೆ ಏನ್ ಮಾಡೋಣ, order of A is finite ಅಂತ ತಗೊಳ್ಳೋಣ. So then what results we get? Based on that you conclude your results. Okay. So let us assume that it is just an assumption. Let us assume that order of A be finite. Order of A inverse be finite. So finite andre it should be a number, a finite number. You take that number is some m, say m. So m is the order. So if m is the order of an element A inverse, that is order of A inverse is equal to m. So that means m is the least positive integer such that A inverse to the power of m is equal to e. ಅಂದ್ರೆ m ಅನ್ನ ನೀವು ಆರ್ಡರ್ ಆಫ್ ಎ ಇನ್ವರ್ಸ್ ಅಂತ ಹೇಳ್ಬೇಕಾದ್ರೆ ಎ ಇನ್ವರ್ಸ್ ನ ಪವರ್ m ತಗೊಂಡಾಗ ನಮ್ಗೆ ಏನ್ ಬರುತ್ತೆ, ಐಡೆಂಟಿಟಿ ಎಲಿಮೆಂಟ್ ಬರುತ್ತೆ. ಅಂಡ್ ಆಲ್ಸೋ m is the least number such that A inverse to the power of m is equal to e. So which implies that m is the least positive integer m is the least positive integer such that A inverse to the power m is equal to e, where E is the identity element. E is the identity, where E is an identity element. Identity element. So okay, so now you take that A inverse to the power of m, yes, this is equal to E, which implies that we can write the same statement as A to the power of minus m is equal to E. Operate A to the power of m on both sides, so which implies that A to the power of minus m into A to the power of m is equal to E into A to the power of m. What is the E? Is the identity element. If you operate any element with E, it gives the same. So E into A to the power of m is A to the power of m only. What about that left hand side? Left hand side it is A to the power of minus m plus m. So which implies that A to the power of 0 is equal to A to the power of m. So actually minus m is the inverse of minus m is the inverse of m. It gives 0. So A to the power of 0 means that is 1, or identity element E. E is equal to A to the power of m. Andre, so that means if you put an if you raise the power of A to m, then it gives the identity element. That means what? ಅಂದ್ರೆ ಏನರ್ಥ A to the power of m ಆಗ್ತಾರೆ E ಬರ್ತಾ ಇದೆ ಅಂತಂದ್ರೆ, so order of the A is less than or is equal to m ಅಂತ ಅರ್ಥ. So what it implies? It implies that order of A is less than or is equal to m. Order of A is less than or is equal to m, or we say that order of A is finite because m is a finite number. So order of A is finite. Order of A is finite, and order of A is less than or is equal to m. Actually, what the statement we considered initially. So we take that order of A is infinite, but finally we get that order of A is finite. ಅಂದ್ರೆ ನಾವು ಏನ್ ತಗೊಂಡಿದ್ವಿ, ಆರ್ಡರ್ ಆಫ್ ಎ ಇಸ್ ಇನ್ಫಿನಿಟ್ ಅಂತ ತಗೊಂಡಿದ್ವಿ, ಬಟ್ ಇಲ್ಲಿ ನಮ್ಗೆ ಏನ್ ಬಂದಿದೆ, ಆರ್ಡರ್ ಆಫ್ ಎ ಇಸ್ ಫೈನೈಟ್ ಅಂತ ಬಂದಿದೆ. Why we are getting this wrong result? So actually order of A is infinity, that is true, but here what we get, order of A is finite. So why we get this wrong result? Because of our assumption. So what assumption we are taken here? An assumption ತಗೊಂಡಿದ್ವಿ. We assume that order of A inverse is finite. So that is wrong. That is wrong. So the order of A inverse is finite is wrong. So that is our assumption. Our assumption wrong ಆದ್ರೆ, which is the correct statement? Order of A inverse is infinite is the correct statement. So order of A is finite, and it is, so this contradicts that. This contradicts that order of A is infinite. Therefore our assumption that, what is our assumption? Order of A inverse is finite. That is our assumption. That assumption is wrong. So our assumption order of A inverse is finite is wrong. So therefore we conclude that, or thus order of A inverse is infinite. Order of A inverse is infinite. And similarly, yes, That is the first case. In first case, we prove that if order of A is infinite, order of A inverse is also infinite. Okay, take the second case. Second case is what? Let us assume that order of A is finite. So that is the case 2. Consider the case 2. Let order of A be finite, be finite. So it is a finite number. You take any finite number as its order, say some n, or write directly order of A is equal to n. That means what? N is the least positive integer such that a to the power of n is equal to e. So therefore n is the least positive integer. N is the least positive integer such that a to the power of n is equal to e. So which implies that, or now a to the power of n is e, which implies that you operate both sides with minus n, a to the power of minus n. A to the power of n into a to the power of minus n is equal to e into a to the power of minus n, which implies that a to the power of 0 is equal to a to the power of minus n, because if you operate any element with identity element, because e is the identity element here, identity element ಜೊತೆ ಯಾವುದೇ ಎಲಿಮೆಂಟ್ ನ ಆಪರೇಟ್ ಮಾಡಿದ್ರೆ ಅದೇ ಬರುತ್ತೆ. So a to the power of minus n is equal to 0, or which implies that a to the power of, this is the identity element, which is equal to a to the power of minus n, which implies that e is equal to, you can write a to the power of minus n as a inverse to the power of n. So that is, implies that a inverse to the power of n is equal to e. If you write the power of a inverse as n, then it gives the identity element. ನಿಮಗೆ ಯಾವುದೋ ಒಂದು ನಂಬರ್ಗೆ ಪವರ್ಗೆ ಎನ್ ಹಾಕಿದಾಗ ಐಡೆಂಟಿಟಿ ಎಲಿಮೆಂಟ್ ಬಂದ್ರೆ ಎನ್ ಅನ್ನ ಆರ್ಡರ್ ಅಂತ ತಗೋಬಹುದಾ? ನೋ, ಇಟ್ ಇಸ್ ನಾಟ್ ಪಾಸಿಬಲ್ ಟು ಟೇಕ್ ಎನ್ ಇಸ್ ದ ಆರ್ಡರ್, ಬಟ್ so it that order of a inverse is less than n. You can consider that order of a inverse is less than n. ಈಗ a inverse to the power of n ಹಾಕಿದಾಗ ಈ ಬಂದಿದೆ ಅಂದ್ರೆ a inverse ಆರ್ಡರ್ n ಅಂತ ಅಲ್ಲ, ಬಟ್ a inverse ನ ಆರ್ಡರ್ less than n ಆಗಿರುತ್ತೆ. So that is the possibility. So now you write that order of a inverse is also finite, so which implies that order of a inverse is less than or is equal to n. So or you write that order of a inverse is also, sorry, order of a inverse is also finite. Order of a inverse is also finite. Okay, next you take that, we don't know what is the order of a inverse is. You just assume that order of a inverse is some m, a finite number. So but ಇದರಲ್ಲಿ ಏನು ಗೊತ್ತಾಯ್ತು ಅಂದ್ರೆ ಆರ್ಡರ್ ಆಫ್ ಎ ಇನ್ವರ್ಸ್ ಒಂದು ಫೈನೈಟ್ ನಂಬರ್ ಅಂತ ಮಾತ್ರ ಗೊತ್ತಾಗಿದೆ ನಮಗೆ. So they can assume that its order is a finite number. Let order of a inverse, you take that order of a inverse is equal to m. So where m is a finite number, so thus a inverse to the power of m is equal to e, where e is the identity element. Where e is the identity element. Yeah, I need some more space. Yes, now a to the power, a inverse to the power of m is equal to e, which implies that a to the power of minus m is equal to e. You operate a to the power of m on both sides. ಇದ್ರ ಎರಡೂ ಕಡೆ a to the power of m ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಆಪರೇಟ್ ಮಾಡಿದ್ರೆ so a to the power of m is equal to u into a to the power of m, which gives that a to the power of minus m plus m is equal to a to the power of m, which implies that a to the power of 0 is equal to a to the power of m, which implies that a to the power of m is equal to e. A to the power of m is equal to e. So we have so what it indicates when we raise the power of a as m. So a na power na m ge raise ಮಾಡಿದಾಗ identity element ಬಂದಿದೆ ಅಂದ್ರೆ what it indicates? It indicates that order of a is less than or is equal to m, which implies that order of a is less than or is equal to m. So now you know that order of A inverse is less than or is equal to n. So from first statement or first inequality, you take this is the first inequality and you take this is the second inequality. From 1 we have, from 1 we get order of A inverse is less than or is equal to n. So which implies that actually what is the order of A inverse is? According to our assumption, order of A inverse is, as we take that order of A inverse is 1, m. So in place of order of A inverse, we can put m. So m is less than or is equal to n. M is less than or is equal to n. You take these inequalities 3 and also from 2, from second inequality we have order of A is less than or is equal to m. Actually what is the order of A? Order of A ಏನು? ಇಲ್ಲಿದೆ ನೋಡಿ, order of A is finite and we take that order of A is n. So you take n in place of order of A. So n is less than or is equal to m. So take this inequality is 4. So is this possible? A number, so we have two numbers m and n. So m is less than n is less than or is equal to m. Is this possible? So ನಮ್ಮ ಹತ್ರ ಎರಡು ನಂಬರ್ಸ್ ಇದೆ. Is this possible? Yes, of course it is possible only when they are equal. In other cases it is not possible. m n ಗಿಂತ ಕಡಿಮೆ ಇದೆ, n m ಗಿಂತ ಕಡಿಮೆ ಇದೆ ಅಂದ್ರೆ ಅವೆರಡು ನಂಬರ್ಸ್ ಏನಾಗಿರುತ್ತೆ? ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ. ಈ ನಂಬರ್ಸ್ ಥಿಯರಿನಲ್ಲಿ ಇದೆಲ್ಲ ಬರುತ್ತೆ. If m is less than or is equal to n is less than or is equal to m, then we say that m is equal to n. Or in other words, you think generally, ಸುಮ್ಮನೆ ಹಾಗೆ ಯೋಚನೆ ಮಾಡಿದ್ರೆ, ಓಕೆ, ಎರಡು ನಂಬರ್ ಇದೆ. ಸೊ ಒನ್ ನಂಬರ್ m ಮತ್ತೆ n ಅಂತ ಇಟ್ಕೊಂಡ್ರೆ ನಂಬರ್ಸ್ನ, m ಲೆಸ್ ದೆನ್ n ಆಗಿದೆ, n ಲೆಸ್ ದೆನ್ ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು m ಆಗಿದೆ ಅಂದ್ರೆ, so it is possible only when they are same numbers. Okay, in other cases it is highly impossible. So from 3 and 4 we have, from 3 and 4 we get that m is equal to n. What is m? What is m? M means that is order of A. What is m? M is, yes, what is here? M is order of A inverse. M is order of A inverse. And what is n? N is order of A. So that means, so that is order of A is equal to order of A inverse for all elements A belongs to group G. If you take any element A in group G, its inverse and that number has the same order. Okay, so that is the property of an order of an element. So, and this is an important property also. So if you have any doubts regarding this theorem proof, I will discuss in live class. Okay. So similarly, you take one more property. Yes, you see this property, that is order of any integral power of an element A of a group G cannot exceeds the order of A. So hope you understand, the order of any integral power of an element A of a group cannot exceed the order of A. And that means what? Suppose the order of A is some 10. Okay. If you take order of A square, if you take order of A cube, if you take order of A to the power of 5, so that element's order is always less than the order of A. Suppose if you take order of A is 10, so order of A square is less than 10, or less than or is equal to 10, order of A cube is less than or is equal to 10. Okay. So like that. So we have to prove this. And as you know that we consider a fourth root of unity. So it is a very good example to consider many properties. When you are discussing many properties, you know that fourth root of unity. So you know that fourth root of unity, it is 1 minus 1 I minus I. As I already discussed this example, you know that order of I is 4. ಇದರಲ್ಲಿ order of I ಎಷ್ಟಿದೆ? 4 ಇದೆ ಅಲ್ವಾ? So if you consider order of I square, order of I square na I square less than or is equal to 4 ಆಗಿರುತ್ತೆ. Okay, because ನೋಡಿ ಇಲ್ಲಿ, if you consider order of I square, what is the meaning of I square? I square means that is minus 1. So sorry, the value of I square is the minus 1. So what is the order of minus 1? Order of minus 1 is 2, that is less than or is equal to, that is the strictly less than 4. 4 means that is order of I. Order of I 4 ಇದ್ರೆ I square ನ order ಅದಕ್ಕಿಂತ ಕಡಿಮೆ ಇರುತ್ತೆ, ಅದಕ್ಕೆ ಈಕ್ವಲ್ ಇರ್ಬೋದು, 2 ಇರುತ್ತೆ. Similarly, you take I cube is minus 1, so its order is 4. Like that, the order of any element is order of, if you consider the integral power of any element, order of integral power of any element A cannot exceed the order of the element A. Yes, it is very simple proof. You consider one group and one element in that group. Let G be a group. Let G be a group, and in this set you take any element A, and you assume that let order of A is n. Order of A is n. So now you take let A to the power of some integer k be any integral power of of A. Okay. So now order of A is what? It is n. So you take A to the power of n means that is an identity element E. Okay. Now you raise the power k on both sides. In the edu kade power k ತಗೊಳ್ಳೋಣ, which implies that A to the power of n to the power k is equal to E to the power of k, which implies that A to the power of nk is equal to E. Or you write that A to the power of nk has, you can write it is, which implies that A to the power of k whole to the power of n, which is equal to E. So E to the power of k E ine barutte, yakandre E into E means it is E only. E into E into E, you multiply any times, it gives E only. E into E up to k times, it gives E only. Like that, E to the power of k is E in this case. A to the power of k to the n is equal to E means what? Order of A to the power of k is less than or is equal to n. A to the power of k na power na n raise ಮಾಡಿದಾಗ ಐಡೆಂಟಿಟಿ ಎಲಿಮೆಂಟ್ ಬಂದಿದೆ ಅಂದ್ರೆ ಅರ್ಥ ಏನು? a to the power of k ನ order less than or is equal to n ಇರುತ್ತೆ, which implies that order of a to the power of k is less than or is equal to n. So therefore order of a to the power of k, order of a to the power of k cannot exceed n. It not exceeds n. So like that, it is very simple proof. And one more property. See, one more property. If the element A of a group G is of order n, a to the power of m is e for some integer m, if and only if n is a divisor of m. N is a divisor of m. To understand this property in better way, you take the same example, fourth root of unity. Fourth root of unity nalli, so you know that order of I is 4. Order of I is 4. So if order of I is 4 andre I to the power of 4 ತಗೊಂಡ್ರೆ ಏನು ಬರುತ್ತೆ, ಐಡೆಂಟಿಟಿ ಎಲಿಮೆಂಟ್ 1 ಬರುತ್ತೆ. I to the power of 12 ತಗೊಂಡ್ರೆ ಅವಾಗಲೂ 1 ಬರುತ್ತೆ. So I to the power of 12 is 1 if and only if this 12 is divisible by 4. If and only if this 12 is divisible by 4. So for example, if you take order of minus 1, that is 2. So if you take order of, so minus 1 to the power of 6, minus 1 to the power of 6 also, minus 1 to the power of 4 if you take, so then also it gives that order of, okay, 1 minute, minus 1 to the power of 2 is 1, that is the order of minus 1 is 2. So if you take minus 1 to the power of 4, minus 1 to the power of 4 is also 1. So that means that, so we are getting an identity element by raising its power is 1 only when this number is divisible by the order of minus 1. So that same property is given here. If the element A of a group G is of order n, so then a to the power of m is e. A to the power of m is e for some integer m if and only if n is a divisor of m. So our m is divisible by n. It is possible only when m is divisible by n.
Stop.
Okay, so to prove this result, or to prove this property, so what we have to prove here? So if n is the order of an element A, if a to the power of m is e, it is an identity element. So then we have to show that n divides m. N divides m. It's first to take that let n be a divisor of m. That is n divides m. So proof of this theorem. Let n be a divisor of m. N be a divisor of m. So you see, 2 is the divisor of 6. Then we can write 6 is equal to 3 into 2. Okay. So like that, if n is the divisor of m, so then m can be written as m is equal to n into some integer. Okay. So therefore, there exists an integer m, there exists an integer q such that m is equal to n into q. M is equal to nq. So which implies that if m is equal to nq, then a to the power of m is equal to a to the power of nq. Which implies that a to the power of m is equal to a to the power of n whole to the power of q. Which implies that a to the power of m is equal to e to the power of q. This is because n is the order of an element A. Because n is the order of an element A. If n is an order of an element A, then a to the power of n must give an identity element E. So what it implies? It implies that a to the power of m is equal to E. Yes, that is the proof in first part. By assuming that n is the divisor of m, we proved that a to the power of m is equal to E. In next part, by assuming a to the power of m is equal to E, we have to show that n is a divisor of m. n is a divisor of m anta prove ಮಾಡಬೇಕು. So that is the converse part. If and only if ಇರೋದ್ರಿಂದ we have to prove its converse part also. So conversely, let a to the power of m is equal to E. So we shall prove that we shall prove that n divides m. Since a to the power of m is E means what? M is the positive integer such that a to the power of, when you put okay, write there like this. Since m is an integer, and n is a positive integer, okay, you take any two numbers, you can write the relation between that two numbers like this. For example, if you take 7 and 3, how can you write this relation? 7, if you divide this number 7 from 3, 3 2s are 6, remainder is 1. So the relation between 7 and 3 can be written like this. 7 is equal to 3 into 2 plus 1. Okay. So here m is an integer, n is a positive integer. Then the relation between m and n can be written like this. So that is called division algorithm. So therefore, by division algorithm, by division algorithm, there exists integers q and r. You take that integers as q and r such that m is equal to nq plus r, where 0 less than or is equal to r less than or is equal to n. Okay, you see this remainder is less than or is equal to, so this number quotient, so the divisor, so remainder ಈ divisor ಗಿಂತ ಕಡಿಮೆ ಇರುತ್ತೆ. Okay, so 0 less than or is equal to r less than or is equal to n. So m can be written as m is equal to nq plus r. Now, so that is m is equal to nq plus r. So now you take this is a to the power of m is equal to a to the power of nq plus r. So that is a to the power of m is equal to a to the power of nq into a to the power of r. A to the power of nq can be written as a to the power of n whole to the power of q into a to the power of r, which is equal to a to the power of n is e, as all of you know that a to the power of n is e. So it is e to the power of q into a to the power of r. And also you know that a to the power of m is also e according to our assumption or our statement. E is equal to, this is e into a to the power of r, which implies that e is equal to a to the power of r. So what is the value of r? What is the value of r? R is the value or an integer that is less than n. R is the value that is, R is the integer, it is less than or is equal to 1, or it is greater than or is equal to 0. It is in between 0 and n. So when you raise the power of a to r, a ನ ಪವರ್ ನ r ಗೆ ರೈಸ್ ಮಾಡಿದಾಗ ಐಡೆಂಟಿಟಿ ಎಲಿಮೆಂಟ್ ಬಂದಿದೆ. ಬರ್ಬೋದಾ? ಬರ್ಬೋದು. ಆದ್ರೆ ನಾವೇನಂತ ತಗೊಂಡಿದ್ದೀವಿ ಅಂದ್ರೆ, so here we consider that order of a is n. ಅಂದ್ರೆ n, ಆರ್ಡರ್ ಆಫ್ a ನ n ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ ಅಲ್ವಾ? ಆರ್ಡರ್ ಆಫ್ a is n ಅಂದ್ರೆ ಅರ್ಥ, what is the meaning? If order of a is n is the least positive integer such that a to the power of n is e. ಅಂದ್ರೆ ಸೊ a ನ ಪವರ್ n ಹಾಕಿದಾಗ ಐಡೆಂಟಿಟಿ ಎಲಿಮೆಂಟ್ ಬರುತ್ತೆ. ಆದ್ರೆ ಸೊ ಅಮಾಂಗ್ ದಟ್ n is the least number. ಅಂದ್ರೆ n ತುಂಬಾ ಅದಕ್ಕಿಂತ ದೊಡ್ಡ ನಂಬರ್ ಹಾಕಿದ್ರೆ ಐಡೆಂಟಿಟಿ ಎಲಿಮೆಂಟ್ ಬರುತ್ತೆ, ಅದಕ್ಕಿಂತ ಚಿಕ್ಕ ನಂಬರ್ ಹಾಕಿದ್ರೆ ಬರಲ್ಲ. So n is the least positive integer such that a to the power of n is equal to e. But what happened here is, here that number r is less than n. When we are putting r in as a power of a, so in that time we get e. Is this possible? So n ತುಂಬಾ least positive integer ಆಗಿದ್ರೆ n ಗಿಂತ ಕಡಿಮೆ ಇರೋ ನಂಬರ್ನ r ನ ಹಾಕಿದಾಗ n ಗಿಂತ ಕಡಿಮೆ ಹೇಗೆ ಬಂತು? So according to division algorithm, r is the value less than n. r n ಗಿಂತ ಕಡಿಮೆ ಇದೆ. So what is the possibility? n ಗಿಂತ ಕಡಿಮೆ ಇದೆ ಅಂತ ಅಂದ್ರೆ r ಏನಾಗಿರ್ಬೋದು? So obviously r ಏನಾಗಿರುತ್ತೆ? 0 ಆಗಿರುತ್ತೆ, right? Since 0 less than or is equal to r less than n, so therefore a to the power of r is equal to e implies that r is equal to 0. Positive integer, least positive integer a ಗೆ a ನ ಪವರ್ ಆಗಿ ಹಾಕಿದಾಗ ಐಡೆಂಟಿಟಿ ಎಲಿಮೆಂಟ್ ಬರೋದು n. ಅದಕ್ಕಿಂತ ಕಡಿಮೆ ಇರೋ ನಂಬರ್ ಹಾಕಿದೀವಿ ಅಂದ್ರೆ ಡೆಫಿನೆಟ್ಲಿ ದಟ್ ಈಸ್ ನಾಟ್ ಎ ಪಾಸಿಟಿವ್, ದಟ್ ಈಸ್ ನಾಟ್ an integer, a positive integer, that is a 0. 0 ಬಿಟ್ಟರೆ ಬೇರೆ ಏನೇ ಇರಲ್ಲ, 0 ನೇ ಆಗಿರುತ್ತೆ. Okay, so a to the power of r is e, which implies that r is equal to 0. So ಹಾಗಾದ್ರೆ r 0 ಆದ್ರೆ r ಏನಾಗಿರುತ್ತೆ? 0 ಆಗಿರುತ್ತೆ. r 0 ಆದ್ರೆ m ಏನಾಯ್ತು? m ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ m ಮತ್ತೆ n ಅಲ್ಲಿ, which implies that m is equal to nq. So if r is 0, which implies that m is equal to nq. So what it indicates? M is an integer, n is an integer, q is an integer. We write m as factor of n and q. Okay, m ಅನ್ನ n into q ಅಂತ ಬರೀಬಹುದು ಅಂದ್ರೆ, so what it implies that? It implies that n divides m. So ಈಗ 2 divides 6 ಅಂತ ಯಾಕೆ ಹೇಳ್ತೀವಿ? ಯಾಕೆಂದ್ರೆ 6 ಅನ್ನ ನಾವು 2 into 3 ಅಂತ ಬರೆಯಬಹುದು, right? So you can write this 6 as 2 into 3. So if it is possible to express this 6 as 2 into some integer, so then we say that n divides, so this 2 divides 6. Okay, so m is equal to n cube ಬಂದಿದೆ ಅಂತಂದ್ರೆ, so what it indicates? n divides m. Okay, so that's all. Okay, next class I discuss some 2 more important properties of order of an element. Okay, so groups topics are like this only. In mathematics, the most difficult topic is algebra, that is groups. Okay, So not only you people, all students are facing this problem. Okay. So I try to convince as much as possible. I know that online classes are or recorded classes are not substitute for ಲೈವ್ ಕ್ಲಾಸಸ್. ಲೈವ್ ಕ್ಲಾಸಲ್ಲಿ ಸೊ ನಿಮಗೆ ನೋಡಿದ್ರೆ ನಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ ಏನು ನಿಮ್ಗೆ ಏನು ಅರ್ಥ ಆಗ್ತಾ ಇಲ್ಲ, ಏನು ಈ ಬೇರೆ ಏನು ಹೇಳ್ಬೋದು ಅಂತ. ಸೊ ಹಿಯರ್ ವಿ ಹ್ಯಾವ್ ಸಮ್ ಟೈಮ್ ಕನ್ಸ್ಟ್ರೆಂಟ್ಸ್, ಒಂದು ಟೈಮ್ ಲಿಮಿಟೇಷನ್ಸ್ ಅನ್ನು ಮುಗಿಸ್ಬೇಕು. ಈ ಥರದ್ದೆಲ್ಲ ಕಂಡೀಷನ್ಸ್ ಮಧ್ಯದಲ್ಲಿ ಐ ಟ್ರೈ ಟು ಗಿವ್ ದ ಜಸ್ಟಿಸ್. ಓಕೆ, ಸೊ ಐ ಗಿವ್ ಸಮ್ ಟಿಪ್ಸ್. ಸೊ ವೆನ್ ಯು ಆರ್ ಲಿಸ್ನಿಂಗ್ ದ ಗ್ರೂಪ್ಸ್ ಕ್ಲಾಸಸ್, ಫಸ್ಟ್ ಟೈಮ್ ಗ್ರೂಪ್ಸ್ ಕ್ಲಾಸಸ್ನ ಕೇಳಬೇಕಾದ್ರೆ ನೀವು ತುಂಬ ಕಾಮ್ ಆಗಿ ಕುತ್ಕೊಂಡು ಕೇಳಬೇಕು ವಿತೌಟ್ ಡಿಸ್ಟರ್ಬೆನ್ಸಸ್. ಆಮೇಲೆ ಆ ಬೇಸಿಕ್ ಡೆಫಿನೇಷನ್ಸ್ ಇದೆಯಲ್ಲ ಅದನ್ನ ನೀಟಾಗಿ ಓದ್ಕೋಬೇಕು. ವಾಟ್ ಈಸ್ ಅನ್ ಆರ್ಡರ್ ಆಫ್ ಅನ್ ಎಲಿಮೆಂಟ್? ಫಸ್ಟ್ ಯು ಶುಡ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ವಾಟ್ ಈಸ್ ಅನ್ ಆರ್ಡರ್ ಆಫ್ ಎಲಿಮೆಂಟ್ ಇನ್ ಡೆಪ್ತ್ ವೇ. ಅಂದ್ರೆ ಅದೊಂದು ತುಂಬ ಡೆಪ್ತ್ ಅಲ್ಲಿ ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ರಿ ಅಂತಂದ್ರೆ ಸೊ ರಿಮೈನಿಂಗ್ ಥಿಂಗ್ಸ್ ಆರ್ ಈಸಿ. ಆಮೇಲೆ ಅದು ಹೇಗಿರ್ಬೇಕಂದ್ರೆ ಯು ಕ್ಯಾನ್ ರಿಮೆಂಬರ್ ದ ಡೆಫಿನೇಷನ್ ಅಟ್ ಎನಿ ಟೈಮ್. ನಾನು ಏನೋ ಹೇಳ್ಬೇಕಾದ್ರೆ ಡೆಫಿನೇಷನ್ ರಿಮೈಂಡ್ ಮಾಡಿದೆ ಅಂದ್ರೆ ನಿಮ್ಗೆ ಅದು ಗೊತ್ತಾಗ್ಬೇಕು ಅದು ಏನು ರಿಮೈಂಡ್ ಮಾಡಿದ್ದು ಅಂತ. ಓಕೆ, ಸೊ ತುಂಬ ಒಂದು ಪೇಷನ್ಸ್ ಮೋಡಲ್ಲಿ ತುಂಬ ಒಂದು ಕಾಮ್ ಸಿಚುವೇಶನ್ಸ್ ಅಲ್ಲಿ ಗ್ರೂಪ್ಸ್ ಆಲ್ಜಿಬ್ರಾ ಕ್ಲಾಸಸ್ನ ವಾಚ್ ಮಾಡಿದ್ರೆ ಬೆಟರ್ ಅನ್ನೋದು ಸೊ ನನ್ನ ಸಜೆಷನ್. ಇಟ್ ಈಸ್ ನಾಟ್ ಲೈಕ್ ಕ್ಯಾಲ್ಕುಲಸ್ ಆರ್ ಡಿಫರೆನ್ಷಿಯಲ್, ಅದು ಇಂಟರ್ವಲ್ ಕ್ಯಾಲ್ಕುಲಸ್ ಬೇರೆ ಪಾರ್ಟ್ನ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡಾಗೆ ಆಗೋದಿಲ್ಲ ಇದು. ಓಕೆ, ಸೊ ಹೋಪ್ ಯು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮೈ ವರ್ಡ್ಸ್. Thank you one and all, and take care.